In basic AC circuit, now we will work out a typical problem. Here I have RLC series circuit, R, L, C, these three are connected in series, and this is our AC voltage source. Voltage is 100 volt angle 0, and frequency of this AC supply is 60 Hertz. R is 6 ohm, inductive reactance XL is 7 ohm, XC capacitive reactance, that is 15 ohm. So we have to sketch the power triangle for this circuit and then find the power factor. Next, find the energy dissipated by this resistor R and the energy associated with L and C. Right? This is the 4 questions to be answered. So we'll find what is the current. By Ohm's law, current equal to voltage divided by impedance. So impedance Z equal to R plus JXL minus JXC ohm. Z equal to 6 plus XL is 7, XC is 15. J7 minus J15 ohm. Z equal to 6 plus J of 7 minus 15 ohm. Z equal to 6 minus J8 ohm. So now you convert this rectangular into polar. So how to convert rectangular to polar using the calculator? I have already explained in my previous video when we discussed about Thevenin's theorem, Thevenin's Norton's theorem, that is circuit theorems involving AC sources. So you can refer to that video so that you will learn how to convert this rectangular to polar by using your scientific calculator. So I request you, please refer to that video. If you already referred, it will be easier for you. So I equal to 100 angle 0 divided by 10. If you convert this to polar, you will be getting 10 angle minus 53.13 degree. So 100 divided by 10. So this is a 10. So angle you take it to the top. So it is going to be 53.13 ampere. So next, the voltage across the resistor, inductor and capacitance, that is VR, VL, VC. So it is a series circuit. So VR is IR volt, VL is IXL volt, VC is IXC volt. So we are just using that expressions. So just substitute. I just now we found out 10 angle 53.13 degree and this is resistance 6 angle 0 because resistance no phase difference. So just you multiply and add this angle 60 angle 53.13 degrees. Then VL equal to IXL volt. I is 10 angle 53.13 degree. So this is inductance, this is the magnitude 7. So in an inductance, there is a leading, the voltage is leading. So we are putting 90 degrees. So just 10 into 7, 70, just add these two things, 143.13 degree volt. VC equal to IXC, So V equal Ixc volt. So this is equal to, so this is I, we have already found out. Here 15 angle minus 90 degree. So this is going to be 150 angle minus 36.87 degree volt. So we have already seen. See, to draw the power triangle, you need three powers. One is P, which is the real power. Next one is S, that is apparent power. And finally, Q, reactive power. So real power P equal to VI cos phi watts. So VI, this is your angle, cos 53.13 degrees watts. So you get 600 watt. Apparent power S is equal to VI volt ampere. So just multiply V into I. So you get 1000 volt ampere. Reactive power Q equal to VI sin phi VAR volt ampere reactive. So 100 into 10 into sin 53.13 degrees VAR. So it comes around Q equal to 800 VAR, right? So next, so using this we can draw the power triangle. So this is 0. So from this is one phasor, real power. Following that we have this reactive power, and this hypotenuse, this is nothing but apparent power S. This is nothing but apparent power S. So we have already seen the apparent power is the phasor addition of real power and the reactive power. Power factor is, there are several ways you can find power factor. This is a common way of finding it. Suppose you know phi, cos phi, that is nothing but power factor. That way also you can find, or you can use this expression, power factor equal to R divided by magnitude of the impedance. R is 6, magnitude of the impedance we have already found out is going to be 10. So it is, power factor is going to be 0.6 leading. 0.6 is 0.6 leading, because this XC, that is the circuit is more dominated by capacitance, as XC is greater than XL, as XC is greater than XL. So it is more or less like a capacitor, more capacitive circuit. So in the capacitor, in the AC circuit with the capacitor, the current leads. Okay, current always leads. So that is the case here. So that's why we are writing 0.6 leading. Next we will find out energy associated with R, L and C. So this is a formula for energy. So the energy with respect to resistor equal to VRI divided by frequency, joules. So VR is the voltage across the resistor, 60. Magnitude, we have to take only the magnitude, multiplied by current magnitude divided by frequency. So this is coming around 10 joule. Likewise, what is the energy associated with the inductance or inductor? So that is WL equal to BL, that is inductor voltage, I divided by omega L. So omega is the angular frequency. Okay, joules. So omega we normally express it as 2 pi f, right? So we write WL equal to VL, we already found out 70, I also found out 10 divided by 2 pi L, sorry 2 pi f. Okay, omega is nothing but 2 pi f. F is 60 hertz. So 2 pi into 60. If you calculate this, this is coming around 1.86 joule. Similarly, energy associated with the capacitor C, WC equal to VCI divided by WC. So this capital WC equal to VCI, again the same formula, 2 pi f. So WC equal to 150. This is the capacitor voltage. Current is 10 divided by 2 pi 60 joules. So if you calculate this, the energy with respect to the capacitor equals 3.98 joule. So this problem illustrated the basic concepts which we have studied so far with respect to single phase AC circuits. Thank you.